Welcome back, Calcsters. Today I have a song stuck in my head so hard that I think it's audible.
Low D high minus high D low, all over low square.
Love it. Love it, love it, love it. Thank you guys for playing along. I know I didn't give you an option, but that's okay. All right. Today we are continuing on, obviously. You are going to have time to work, but I want to work through a few kind of ugly problems together. So, thank you. I think I probably talked loud enough that it would pick it up at least a little bit, but the audio quality would be garbage. Okay, so we did one quotient rule yesterday. There's another rule that we don't have a song for. We could probably come up with one when we produce this musical and sell it to Broadway. What's the other rule, though, that we talked about? Quotient rule, we all have locked in, seemingly. The product rule. And I assume that there's a sweet rap song in there somewhere. I'll collaborate with my best pal, Kendrick. I couldn't name a single Kendrick song, just for the record. I'm too cool. All right, let's check it out. Product rule. First times the derivative of the second plus the second times the derivative of the first. There is a song in there. I just don't know it. Quotient rule. Low D high minus high D low all over low squared. Cool. We have them. We did one quotient rule yesterday. I'm not going to tell you which rule it is. It'll be fairly obvious, I believe, here in just a second. But we're going to do kind of ugly derivative real quick. So we're going to find d dx is what I'm looking for. And I'm going to use brackets for the big one because there might be a couple parentheses in here. Okay, for our first, let's say that we have x squared over 2 minus 2x. And I'm going to put parentheses around those two bad boys. And we also are going to try to multiply this by 1 plus 2 e to the power of x. Okay. With this problem, right off the bat, can you tell me which rule we're going to use? It's going to be the product. Now, if you want to think about it, like I never think f and g and things like that, but when we wrote it down, we used them. It doesn't really matter which one is f and which one's g, if we wanted to think about it that way. It doesn't really matter in the end, but this would naturally be f and this would be g. Okay, I'm not going to write it out here, but let's go ahead and get kicking. The first, can we all agree, is f? Okay, so if we start working this, we do first, just first. Nothing changes. So it's x squared over 2 minus 2x. There's the first function. Now we take the first and we multiply by the derivative of what? The second. So here's where I need your guys' input. Do you need me? Do you want me to write d dx of this? Or do you just want to take the derivative right here, right now? Okay, so we are just taking the derivative. And I'll make sure I highlight that. But what is the derivative of 1? 0. What's the derivative of 2e to the x? So here it is. First times the derivative of the second. And I'm just going to write for our purposes. You don't need it, but this is g prime. This is f. First times the derivative of the second plus, what's the second function again? 1 plus 2 e to the x times the derivative of the first. This one, 2x over 2. Can we just say that that's x? Or 1/2 times 2x is just x. Minus, what's the derivative of 2x? 2. And again, first times the derivative of the second, plus the second, here's g, times the derivative of the first. Here's f prime. If all we were asked to do at all was to find the derivative, should we go further than this? I don't know. Don't look at me. I mean, I do know, but what do you guys think? If the only instruction is find the derivative of this, have we done that? We're done. Now, that is super nice. What we need to make sure we're able to do, and I'm going to trust your guys' judgment on this, is if this were a multiple choice problem, is it possible that it wouldn't be presented like this? So there's a million things that we can do with the algebra to try to clean it up. Like there's no set rule on what makes this look nice. We probably all agree in general what is nicer than something else, but what's the nicest form is going to vary between what we're using it for. Do you guys want to go through the process of expanding this? Do you want to say we're good, we'll stop where we're at? Thoughts? Like, can everybody FOIL it if we had to? Like, I don't really want to. Okay. While we're looking at this, couple things that are worth talking about. Does this seem super hard, first of all? Like, it's easy to get lost. We'll come up with a song, or we can all collectively come up with a song. I kind of love the idea of writing a musical. Just like, if somebody presented the idea, I'm going to write a musical about our founding fathers, I would say that's dumb. But then it turned out to be like $1 billion idea. Maybe there should be a Newton and Leibniz feud musical on Broadway. Throwing it out there. Okay, we're going to look at one more, and I just want to kind of show you guys. I know that if I say, hey, here's a bunch of different options to solve a problem, sometimes that can kind of muddy up the water, right? However, here, if we know the product rule, we know the quotient rule, you're always good to use either. But I do want to look at a situation where maybe we wouldn't necessarily use one or the other because they both work fine. So let's look at a fairly nice one here. Let's say that we get a function f of x is defined to be x cubed plus 4x squared plus 1 times, I don't know, 3x minus 2. Okay. Oh, we could have done a third function too. Nope, we'll just do 2 here. Okay. As we're looking at it, what rule are we going to use to find f prime? Product rule. Now, we could do it, right? And it's not crazy difficult, I don't think. I'm going to implement the product rule. I'm going to give you guys like 30 to 60 seconds. I want you to write me f prime using the product rule. And then I want to look at it maybe a different way, just to see that if you don't love the product rule, inevitably you will have to use it at some point. But maybe there's other options on problems. I'll give you just a second. Okay, here's the first. What do I multiply this by? 3. Why 3? It's a derivative of 3x minus 2. Plus the second, I always do it in this order, times the derivative of the first. What is the derivative of the first? 3x squared plus 8x. Cool. Some people in here will switch these around. Is that okay? Yes. I will never switch them around because I am a creature of habit. Okay. If you wanted to do this problem, like, we could FOIL these out and it's all fine and dandy. Now, this is not a great example of it, but it doesn't matter if it's this particular problem because the concept works regardless. Is it possible that you get to the test, the quiz, whatever it is, and all of a sudden you're like, crap, I don't remember the product rule at all? Like, hopefully it doesn't happen, but I mean, it's possible, right? Now, if for whatever reason you had a blank and you forgot it, could we look at f of x differently? I'm going to say or. If we don't remember the product rule, does it mean we're completely boned here? I don't think so. Why not? So I could use the quotient rule. It'd be a weird one to use, but we certainly could use a quotient rule for this. Not what I'm going to suggest, though. Could we do this if we wanted? Like, we could actually just multiply it. Now, this is not meant to be just an exercise in foiling or anything, but I think it's 3x to the 4th. And let's see, I'm going to get a plus 12x cubed right here. And then I'm going to get a minus 2x cubed at the end. So I see it's going to be plus 10x cubed. Like, I'm just trying to FOIL it out without showing all the work. Nope, this is just f. I'm just rewriting the original, in case I'd forgotten the product rule. Now, I'm trying to FOIL this out, and I lied. I'm just going to actually do it all because I'll probably make a mistake. I think it's going to be 10x squared. Do we agree it's 3x to the 4th plus 12x cubed plus 3x? And then the second part is going to be minus 2x cubed minus 8x squared minus 2. And all I'm doing is I'm rewriting f of x originally. I haven't even thought about the derivative yet. I mean, we did, obviously, but now we haven't. Okay, so when we clean this up a little bit, this is 3x to the 4th plus 10x cubed minus 8x squared plus 3x minus 2. Even if I made a mistake, I'm not super worried about it because the same point's going to be made. I don't think I did. Did anybody see a mistake there? Now, this is only if we had forgotten the product rule, right? I would never actually do it this way unless we had to. Do I need a product rule anymore? No. And there's times where it would make sense to do this, and I'm going to ask for your guys' judgment on that. If we did f prime of x this time, what's the derivative of this? We'll just do each piece. 12x cubed plus 30x squared minus 16x plus 3. Okay, I wish I had not drawn the red bar through it, but I'm glad I didn't erase it. Do these two look the same? They do not. If I said, find me the zeros of the derivative, do you think this one in green that I drew the red bar through, is it easier to solve the equation if I set 0 here, or is it easier to solve the one down here with 0? You think it's the top one? I disagree with you completely. Because if this were a multiplication here, you could use the zero product property and it would be easy, but it's not multiplication. If you wanted to do it, you're going to have to wind up foiling these out anyway. If I needed the roots, the zeros of my derivative, this is the much better choice to use. Now, whether you do it by foiling it out here or on your calculator, or if we check real quick, and let's do verify, grab your calculators, because I'm very curious, and I want to show you not a shortcoming necessarily, but a possible issue. On your calculators, we are doing some calculus, right? Like there's algebra involved, obviously. But on your calculator, if you hit, is it F2 for calc? F3? On F3, there's an option, the very first option, it says to differentiate. I want you guys to ask it to differentiate our original. Now, when somebody gets error too few arguments, I'll come and chat with you because I want to make sure we can figure out what that means. But I want you to try to take the derivative of this guy on your calculator. I have no idea what it's going to give us. Something different is my guess. So the original function, let's do this. Sorry, let's do this one. Because we're right, both of these. This is the derivative of f. This is the derivative of f. I don't know what your calculator is going to tell us is the derivative of f. I feel like my mouth is full of marbles when I say derivative of like when I say it over and over, because it just comes out as derivative. Ooh, error. So hit enter for me real quick. Does it say too few arguments? So how many of you got too few arguments? Okay, it means that you're asking it to find a derivative, but you haven't told it the variable. When you type this in, and I don't have an 89 to show you, but I'm going to type it in on this one, and I obviously. So these ones actually can take derivatives. Nowhere near as nice. What's up? You got it? Okay. So let's check it. Okay, too few arguments. This is the most common. When we look at our calculator screen, there is a telltale sign that tells us what's going on. When I look at this, does it say d dx at the beginning? Does it? It just says d. It doesn't know what it's taking the derivative with respect to. So, JJ, this is your typing. Love it. Notice JJ added an extra parenthesis so that this expression, x cubed plus 4x squared plus 1, has parentheses, times 3x minus 2. He closed that parenthesis, and then he closed the end. We are taking the derivative with respect to which variable? If we want it to do that, I'm going to hit the comma, which is above 9, and I'm going to tell my calculator, do the derivative with respect to x. When I type this in, it no longer will tell me error, too few arguments. I can see very clearly that it's done now because I've told it d dx. And notice, when we type in the derivative, I get 12x cubed plus 30x squared minus 16x plus 3. Hey, look at that. It gave us this form. Now, they're both the same. Your calculator will regularly give you a different form than you're expecting. If I hadn't talked about this, you might be kind of puzzled. I assume that you probably know that it did just simplify it down. Don't just blindly trust your calculator, especially if, like, you need to be able to do them without the calculator. Calculator is always good to check with it, but be prepared that it might be a different form. Cool with that? All right, so we can do that one using these lovely rules. Could we do the same thing, similar thing, do you think, with the quotient rule? Now, for these examples, and I think I only want one more, and I'm going to give you guys a bunch of time. Before we move on, What do you prefer, product rule or expanding it and then using regular rule? For just finding the derivative, I say product rule. It's so much faster, it's easier. But if you're going to do something with it, like if we need to know the zeros, anything about the derivative, this is a much nicer function to work with. You could go from here to here by foiling after the fact. It's entirely up to you. You get some options. Okay. I want to look at the same thing. Last example. And it's going to feel super wonky. Gosh, what's the quotient rule again? Okay, cool. So I don't really sing it obnoxiously every time, right? In my head, all I really think is low D high. Like, no, okay, not really. Low D high minus high D low all over low squared. I'm boring. Just like quadratic formula, did you guys learn it with a song? Negative b plus or minus the square root of b squared minus 4ac all over 2a. I did not learn it that way. I know Ms. Carr taught it that way, and I probably will teach it that way with algebra in the future because sing-songy helps for whatever reason. In my head, it's the most boring version. Negative b plus or minus the square root of b squared minus 4ac all over 2. Like, that's what I hear in my head. I don't know. Anyway, here we go. We're going to look at one more variation. And we're not going to do a super ugly derivative here, but let's say it's 3x squared plus 2 over x cubed minus 1. Okay, is it a very clear quotient rule? Okay, so first off, I want you guys to do the quotient rule for me. And then we'll look at, similarly, there's maybe another way we could view it. I'm going to give you guys a second. I'll give you a head start. If you're watching the video from elsewhere, pause it now. Try to do this with the quotient rule. Low D high minus high D low all over low squared. Cool. I will resume in 3, 2, you know what to do. In the worst case scenario, if I happened to completely forget the quotient rule, which you won't because we'll all sing it, and we have all sung it, and my hope is that you remember the words and the song, can I view this function differently? Like, and obviously the answer is yes. Can I view this as a multiplication instead? Okay, so this one's going to be a little bit further out there, but it's a good point to review some of this. This is 3x squared plus 2. That's my numerator. And this, we don't do it here either, but this is to the first power. Nothing crazy. Is this one also to the first power? Could I then write this as x times x cubed minus 1 to some other power? What power would I write it as if I needed to go down to the denominator? Not the 0. To the negative 1. If I do this, could I use the product rule? I think so. Now, we're not going to right now, and I'm not going to give you the big reason to why, because we'll need one. I'll tell you. There's an additional rule that we need, but that's our next section. But the fact that I can rewrite this quotient as a product seemingly is going to make this nice. Everybody agree with that? Maybe not nice necessarily, but gives us an alternative route. Okay, with this, if anybody's taking calc, and I know that a few people have seen some stuff, we need a chain rule for this is what we really need. And if you have no idea what that means, that's okay. All right, I want one last little tiny problem, and then the rest of the time is yours. And I said that like 3 times, so I'm sorry that I keep lying right to your faces. You know what? I am really sorry. I was going to say I'm not sorry, but I'm not intending to do that. Last one. Okay, this one's going to look a little different. We have a particle or an object. An object's velocity is given by, let's say we have v of t equals, I don't know, we'll say it's nice, t squared minus 1 and t squared plus 1 with t in, we'll say seconds, and distance, and I know we don't have any distance written here, we'll say distance in meters. Okay, so it's meters per second is all that we're working with. Okay, here's our statement, and we'll chat it out. I want you to find the acceleration. We'll call this a of t for the object. Now, I didn't say the instantaneous acceleration, so we're just looking for some general way to do this. Okay. This question feels a little different than the last problems that we did. I assure you it's the exact same thing, but we're going to make sure that these physics concepts connect a little bit. If I have position and I measure how much it changes over some amount of time, I've went from position to what? So I'm at 1 meter right now, and if I said over the course of 3 seconds, I moved 3 more meters. You can calculate out my, instead of position, my velocity. The derivative, or the rate of change of position, is the velocity, right? What if I want to know how fast is my velocity change? Like, here I'm walking at 1, and then here I'm walking at 2. Did I increase a little bit? What's the physics word there? So how fast velocity changes is acceleration, right? What do we use to calculate how fast something changes, or a rate of change, a slope, if you will, in calculus? We take the derivative. Acceleration, because it's the rate of change of velocity, if I give you the velocity function, how do we get acceleration? You take the derivative. That's it. So, your guys' job for me, and this will be pretty quick, I know that a of t, the acceleration, is exactly the derivative of the velocity. I don't know why that was so light. Acceleration at time t is the derivative of the velocity at time t. Now, alternatively, you don't have to write this one, but I just want to make sure we have it. This would be d what? Not x. T in this context, right? d dt of velocity, v of t. Cool. Same notation or same question, 2 different notations. Whichever one you're going to use this one, it's easier. Find me the derivative real quick. I'm going to give you a moment. Now, I don't want our problems to turn into like pure algebra exercises where it's just rewriting a million times, but I want to work with the following convention. On an AP test, stop here, just for the record. In here, when we're actually doing stuff, is there an obvious algebra that we could do here? So you say FOIL. You could FOIL it all out. I don't know that I would think that makes it nicer. Maybe it does, and that's that subjective part. But what about if we go the other direction? Is there any obvious factoring that can happen? More than t. A little bit more than 2t. Dang it. A little bit more than t. They both have a 2t, don't they? If we do this, I think that this is reasonable. I'm not going to include the parentheses here, and maybe we'll talk about why. T squared minus 1 plus t squared plus 1. Everybody agree that that's what would be remaining? Okay, and again, I'm going to give some leeway on this. Is there any obvious algebra that one could do? Like, is there like very clear and simple simplifications that we can do? What's inside? 2t squared. Now, maybe I would go one last step because, again, in my mind, it's obvious. But if it's not to you, like, I'm going to take your judgment on that. Simplest way we can write this acceleration? 4t cubed. 2t times 2t cubed. Sorry, squared, 4t cubed. Okay. Everybody all right with that? Okay. Last, this, you can write it down if you want. It's a fun fact. If I start here, what is this? Seconds in time. So this isn't seconds. Position. Okay. If I differentiate this with respect to t, so we'll just say, check it out. Here we go. d dt. I wind up with what? Velocity. Velocity. If we take the derivative of this, d dt, what do I wind up with? Acceleration. And I don't know the letters that get used for these next ones, but here's our fun fact. What if I take the derivative of this? How fast my acceleration changes? Anybody remember this one? And I'm going to move this over just so I can write them all. Sorry. Okay, so this one, it does have a name. I'm not going to, I assume I know what it is. I bet it's J of t, regardless. Okay, two ways that this is referred to. Jounce, which I don't like that one. It just doesn't mean anything. It sounds like a fake made-up word. But all words are made up, so maybe that's not really that important. The one that I prefer more is jerk. If you think about, if you've ever ridden with somebody who likes to kill a manual car, like, it's really jerky, and you're feeling changes in how fast the acceleration is happening, that, like, being jerked around like that is a good way to think about this. Okay, now, we all know that out of all professions, physicists and mathematicians are the most clever and funny, right? Okay, what do you think we call it? And I'm going to switch to blue. These first three guaranteed you need. I kind of doubt that you would ever encounter jounce in anything that we'll do in here. But we do have three more. Anybody remember what the derivative of jounce is called? I'm not going to use S, but it's snap. The snap, how fast your jerk changes, is called the snap. Okay, could we go further? So we will, and we do. And I wish I could tell you, outside of jerk, it is very hard for me to conceptually make sense of what, like, it would even mean. Like, a huge snap, I imagine it's going to hurt, I would guess. But next one is crackle. All right, Abigail, you hit it. It is the right answer. If we have position and take the derivative, it's velocity, whose derivative is acceleration, whose derivative is jerk, whose derivative is snap, whose derivative is crackle, whose derivative is, it's the pop. Yep, it's the real one. Like, legitimately, mathematicians, physicists, funniest people alive. All right, you get an assignment. And I already gave you the assignment, I believe. Is it 9 through 39 odd? Fantastic. Really kind of want to add the AP problems, but I won't. Okay, you guys get the next 18, 17 minutes to nominate me for a Beacon Award, and then just kidding. But do the homework. Cool. Start working. I want to help. You need to ask if you want help. I try not to be super nosy. Do it to it. Just not a threat, but just so you know, I am 100% excited and prepared to start the next section. We can and will if needed. Sweet.